Did anybody get E, something like 9.43 E negative 4? Anybody get that? Okay, so what that means is you have an exponent. You need to move that decimal place over how many places?
4 times.
4. Should it become smaller or larger? Smaller, because it's negative. So what you do is, here's the easiest trick. Everyone pay attention. Everyone look up. If you get this on your calculator, and you will at some point, you're going to add, it says 04, you're going to add 4 zeros in front. And decimal place goes after the first one. After the first zero. Everybody good with that part? Okay. So that means that our number here is 0.000943. Has anyone found the expected value yet?
Yeah.
Okay, so I will call on somebody randomly to give me the expected value, right? So check it with your neighbors, 15 seconds.
You do it with this difference. So x times
Anybody not talking to the neighbors that I'm more likely to call on? Okay, so goes way. How do I find the expected value? What do I multiply or add or whatever? Tell me what to do.
Multiply 0 by 0.999057.
Perfect.
And then you add. And then you multiply negative 100,000 times 0.000943.
Great. And Rachel, what do you do when you get this?
you multiply the 0 times the one in parentheses,
Yes.
and so 0. And then plus negative 100,000 times the one in parentheses, and that's 94.3, or negative 94.3.
Great. So they're going to pay out, on average, $94.30. How much money do they get? How much money does this policy cost them? How much money do they get for this policy? How much money do they get for the policy? $360. So their net profit is their total expected value, right? Their real expected value. This is just for the payout. Is going to be 360 minus 94.30, which means that they should stand to make what, $265.70 a year on the policy. All right, which is why insurance companies are in business, because they make money off of that. Now, on the flip side, they do have, they have people they have to pay, right? They have buildings they have to, have and stuff like that. But still, yeah. I don't get life insurance. Okay. Now we're switching into the binomial distribution. So we're on to 5.3, I believe it is. Binomial distribution. I need a good reader. Alina, go ahead and read for me.
A binomial experiment is a probability experiment that satisfies these requirements. Don't read all.
Yeah, but pause in between.
One has a fixed number of trials.
So it has a fixed number of trials means that I know before go ahead and read all of them, and I'll talk about them afterwards. Keep going.
2, each trial has only 2 outcomes. 3, the outcomes of each trial must be independent of each other. 4, the probability of success must remain the same for each trial.
Perfect. That's good. All right, good. So you folks are filling in blanks, right, for this part. It's the bottom of page 3. Everyone's filling in 1, 2, 3, and 4. I'm going to talk about them for a minute. So binomial. You've heard bi before, bicycle. Bicycle means it has 2 wheels, right? Bicentennial means 200 years. Binomial experiment means that there are 2 options. It only has 2 outcomes. So binomial experiment, one basic one is flipping a coin. You either get heads or you get tails. But you can make anything into a binomial experiment by having it just be is or isn't. For example, I could say I roll a dice, and I either get a 4 or not a 4, right? I choose a person. Either they have brown hair or they don't have brown hair, right? Or I pick somebody, either they own a dog or they don't own a dog. So you can really make anything into this binomial situation with two outcomes. The thing about the outcomes is they have to be at each trial. So, all right, so each trial has only two outcomes, and then you have a fixed number of trials. So in other words, I'm going to do this trial, flipping a coin, a certain number of times. And I know ahead of time, before I even start, how many times I'm going to flip. I know before I start when I'm going to stop. I'm going to flip a coin, and I know I'm going to stop at 8 flips. That's my fixed number of trials. Or I'm going to choose, I want to know if people have a dog, so I'm going to choose 7 people. I know ahead of time I'm going to stop at 7 people. That's my N, my fixed number of trials. The 3 and 4 is the probability of each of those outcomes has to be independent of each other. So in other words, I flip a coin, it does not affect the next coin flip. I pick a person to see if they have brown hair, it does not affect whether the next person has brown hair. Right? They have to be independent and identically distributed. In other words, they need to be all the same probability. Right? Okay. That's how you know it's binomial. The key thing with binomial is you're doing something over and over again, and whatever you're doing only has 2 outcomes, like flipping a coin or picking a person to see if they are or aren't. So that's the key of figuring out binomial. All right, so here's a question. Alex, read for me.
If I have 10 marbles in a bag and 4 are white, then I draw a marble to see if it is white or not. I do not replace the marble, and I repeat the trial 4 more times. Is this binomial?
Okay, everyone check the 4 requirements. You've written them down. Is it binomial or not? Talk to your neighbors, 15 seconds.
The thing is that the outcomes of each trial must be independent.
Okay, so first question. First question. Am I doing something over and over again and I know ahead of time how many times I'm going to do this? Yes, I know I'm going to draw it once and then 4 more times, so a total of 5 times. Okay, now each draw, does it have only 2 outcomes, is or isn't? Yes, it's either white or not white. Good? So possibility 2 is done. How about 3 and 4? Does it probably stay the same for each draw? No, because I don't replace the marble. So you don't replace the marble, all of a sudden they'll probably change each time you draw it. Correct?
Yes.
Or it starts off with 4 out of 10 being white, and then once you draw it, it's no longer even out of 10, now it's out of 9. So this would not be binomial. Right? Okay, but what if I draw 5 marbles and replace the marble each time?
Yeah.
Now is it binomial? Yes, because now the probabilities are all the same. Everybody each time. Each time the problem, if you replace it, each time the probability of drawing a white marble is 40%. Everybody feeling a little bit better about this now? You know, a concrete example? All right. So here's some notation for the binomial distribution. This first little fellow is called little p. I like to think of him as like a rapper. Little p, little p, little p. All right, we got little p, we got little q. Little p is the probability of success for one trial, not the whole thing. The whole thing, that probability is big P. But little p is the probability of success for just one flip of the coin, or one roll of the dice, or one draw of the marble. Little q is the probability of failure. So in other words, 1 minus little p. Little p and little q, they have to add up to 1 or 100%. It's either you draw a white marble or you don't. N is the number of trials, in other words, how many times you're drawing. And then X is the number of successes out of N trials. And note, how many successes could you have? If I flip a coin 6 times, how many heads could I have? 6. Or, if I flip a coin 6 times, I could have 6 heads or what? Or 1 or 0. Don't forget 0 the hero. I could always have none, right? I could have anywhere from 0 up to 6 if I flip the coin 6 times. I can't have more than 6 if I flip it 6 times. But I could have anywhere from 0 up to how many times, up to N, how many times I do it. Do not forget 0. You could always have 0 successes. So your X could be any one of these numbers. So you can find the probability of any one of these things being true. The probability that you get 1 success, probably you get 2 successes, probably you get 3 heads, right? Those are all possibilities. And in fact, we saw that actually yeah, I don't have that, so I won't pull that up. All right, so the binomial experiment, the probability of exactly X successes in N trials is, write this into that space right there, big P, the probability of, right, capital P means probability of X is equal to N choose X. You guys have seen that before. We saw that in chapter 4.6, N choose X. So now you can use a calculator to find it, that's no problem. Times little p raised to the power of X. Multiplied by little q raised to the power of N minus X. Now you all know I hate to have you memorize formulas, so let's look at a tree diagram to understand this formula and know where it comes from. Everybody have it written down? If you don't have it written down, take a picture of it. Copy off your neighbor. Wait in 5, 4, 3, 2, 1. Okay, so say a couple had 3 children, right? They have a 0.6 chance of having a girl, 0.4 chance of having a boy. Here is a tree of all the possibilities. Good? Probability tree has all the probabilities on there too. So they're doing something over and over again with only 2 outcomes. What are they doing? They're having a child. How many times are they doing it? 3 times, right? So first one, boy or girl. Second one could be boy or girl. Third one could be boy or girl. So they're doing this experiment 3 times. Right, their N is 3. And here's the probability tree for that. We want to know the probability of having exactly 2 boys. Exactly 2. Then our success is having a boy. And little p, right, probability of just one child being a boy is 0.4. Which means little q, our probability of failure, right, having a girl is what? 0.6. They have to add up to 1 or 100%. Everybody on board with that part? Now, what's our N? What's our N again? We're having 3 children. 3. We're having 3 kids. What's our X? 2. Remember, X stands for the number of successes. You just wrote that down, right? Or you just wrote down X under that. All right, so what's N minus X then? What's N minus X? 1. What does 1 represent? What's 1 represent? How many failures, right? How many girls I have. I can only do that because I'm a girl, otherwise I'd be in trouble. All right, everybody good with this part? So N minus X represents your number of failures, X represents your number of successes. Good? Everybody on board with that part? Okay. So, let me go back to this. So, this, well, I'm sorry, we'll go forward. All right, so for exactly two boys, X equals 2. So in this case, a boy is a success. N is 3. So all the ones that have exactly 2 boys, let's circle them. Boy, boy, girl. Boy, girl, boy. This one's not, it has 2 girls. This one has 2 boys. That one has 2 girls, and 3 girls. All right, so just those 3. Everybody with me on that? Those are the 3 outcomes that have exactly 2 boys. What do they have in common? Look at their probabilities. What do they have in common? They both have 0.4 being multiplied twice and 0.6 being multiplied once. Does everyone see that? Because as you go to the tree to get there, you're going to have two G's, one G and two B's. Every B is a 0.4 probability. Every G is a 0.6 probability. So all of them have 0.4, the probability of a boy, raised to the second power because you have two boys, and the probability of girl raised to, or your Q, raised to 1 because that's the number of failures. Does everyone understand? So that's where this part comes from. Oh, and the other question is, how many of them are there? How many things have I circled here? 3. Why is that? Because it's saying how many ways can I have 3 people and randomly pick 2 of them to be boys. So here are my 3 children, I'm going to say, okay, you 2 are boys, or you 2 are boys, or you 2 are boys. So how many ways can you randomly pick 3 items and randomly assign 2 of them to be boys? So here, these are all ways I can have 2 of them be boys, and how many ways I can arrange that? Different ways I can arrange 2 boys out of 3 items. So that's where this tells me how many of these will end with 2 boys and a girl, and this tells me the probability of each of those. So I'm going to have 0.4 to the second times 0.6 to the first 3 times. 3 choose 2 times. That's where this formula comes from. That's where this formula comes from. All right, so I think I don't need this. Oh, right. What if we're doing 4 children? How many ways are there of getting 2 boys? 2 boys. Let's see. Boy, boy, girl, girl. Boy, girl, boy, girl. Boy, girl, girl, boy. Girl, boy, boy, girl. Boy, girl, boy, girl. Girl, boy, girl, boy. And girl, girl, boy, boy. There are 6 ways of getting 2 girls and 2 boys. That should be 4 choose 2. So what's 4 choose 2? It's 2 spots. Start with a 4. Then you have a 3, and I divide by my duplicates. 2 times 1. 4 times 3 is 12 divided by 2, 6. Right? So does everyone understand this idea? That's how many. So the n choose x tells you how many trees end up with what you want. And right, so that's this part here. So the n choose x tells you how many outcomes with exactly x successes among n trials. There's how many of those branches end up there. And then the p to the x times the q to the n minus x tells you the probability of that branch. Right, so then you're going to have this probability. You can either add them, but you can add them all up that many times, or just multiply them. Right, I can either add 0.1 4 times, or I can just multiply 4 times 0.1 and I get the same thing. So you can add them all up. This tells you how many there are, or you just multiply these 2 and you get the same thing. So that's where this formula comes from. If that didn't make sense to you, then you better have this down in your notes and just use the formula. That's fine too. I'm kind of alright with that. I spent an hour explaining to my class one time, and then only 2 of them got it on the credit on the exam, so I just gave up. That's okay. It's alright. It's a lot for you guys to take it. So no worries. Yeah.
I just wanted to bring you the last one.
Oh, do you have your camera out?
Yep.
Okay. Going in. Okay, there we go. Great. All right, so here's some notation you folks need. So just as a quick reminder, we talked about this already. N denotes the number of fixed trials. X denotes the number of successes out of n trials. And remember, it can be any number from 0 to n, any whole number. can't have 2.5 successes. Any whole number between 0 and n. Little p denotes the probability of success in one of the n trials. Little q is the probability of failure in one of the trials. And then big P, the probability of x, is probability of getting exactly x successes among n trials. All right, so let's take a look at this together. Sarah, go ahead and read for me.
Example survey on doctor visits. A survey found that 1 out of 5 Americans say he or she has visited a doctor in any given month. If 10 people are selected at random, find the probability that exactly 3 will have visited a doctor last month. My RV, X, is the number of people in the sample who visited a doctor last month.
What is n, what is x, what is p? Everybody find those 3 things. Find x, n, x, and p. Let's go 15 seconds on your own, and then 15 seconds talking with your neighbors.